other week we looked at the different molecules in solids, liquids and gases, and today we are going to be looking at the properties of solids, liquids and gases. Now properties mean the things that are specific, so the things that are just for that state. So we're going to have a little look at solids first, then liquids, then gases. There are solids all around us. Me sitting here at this moment in time, I've got wood beside me, granite, plastic, slabs, a bucket, it's all solids. So I'm going to tell you about the properties of solids, meaning what makes a solid a solid. The first property to describe solids is that they are a fixed shape. They cannot change their shape unless someone else does it for them. So for example, you might snap something, you might hit something, you might squish it, it will change its shape that way, but if I left this piece of wood on its own, it wouldn't change its shape. However, I can change the shape of a solid. Chalk is also a solid. It is not going to change its shape. However, an outside force, me, with a hammer, I can change its shape. A solid cannot change its volume, and volume means the amount of space that it takes up. So for example, I have some Lego here. This is a Lego tower and it's made up of 4 pieces of Lego. However, if I change the shape of the solid, because it can't change it itself, I could place them beside each other. It's a different shape now, but it's still made up of 4 Lego bricks, so it's the same volume. 4 Lego bricks takes up the same space as 4 Lego bricks, which are piled on top of each other. We also know that the molecules of solids are tightly packed together and they don't move themselves. So the main properties of solids are they are a fixed shape unless we do something to them. We hit them, we squeeze them, we squish them, and their volume stays the same. Even if they've been broken in half, you can still put them back together. Their molecules are also tightly packed together. Next we're going to talk about liquid. Now the first property of liquids is they can flow, and that means that you can pour them. So you might pour your milk, you might pour juice. You could also pour honey, but honey just flows slower. It's a bit more gloopy, but it's still a liquid because it can still pour. Okay, now liquids can change their shape. I have a solid here first of all, and if I put a solid in this container, the solid is still the same shape. If I put it in this container, the solid's still the same shape. This one, the solid is still the same shape. Now, a liquid doesn't have a fixed shape, so you can put it into a container and it will take the shape of that container. So, if I pour it into this one, it's now in the shape of this container. It's gone all curvy around the sides. If I take the water and now pour it into this one, it's now in the shape of this container. It's changed the shape. And now if I pour this into this container, it's changed its shape again and is the same shape as this container. We know that water can change its shape like this because of its molecules not being as tightly packed as a solid, having a little bit more room so that they can fill up whichever container you put it into. Finally, we have the properties of gases. Now, gases are all around us, but we can't necessarily see them. Gases like oxygen, carbon dioxide, helium that might be in a balloon. Now, gases can change their shape. Unlike the solids and liquids, we know that gas molecules are really far apart. So they have room to squeeze into each other, and we can compress them and change their shape. One example of this would be a gas canister. Inside here we've got lots and lots of gas that's been squished into a smaller shape, and then when you spray it, all the gas comes pouring out and expands to change shape to be in the air around us. Another way that we can see that gas can change its shape is the different types of helium balloons that you might have. You can get ones in numbers, you can get ones that are different shapes, and the gas fills up those helium balloons, and so it can change into the shape that the helium balloon is. Gases can also change their volume. At the moment, the gas inside this container is very tightly packed. It's quite small. If I put all this gas into a bigger space, it would totally fill the bigger space because those molecules are full of energy and they're bouncing around, so it would fill whatever space you put it into. That's why when you spray something like this, you can smell it all around you in the air because it's filling up all the space that it is in. So that was a super quick run through of the properties of solids, liquids and gases. Now there are loads more videos on YouTube that can go a little bit more in depth if you want to have a little look and see some more information about solids, liquids and gases. What we're going to do is there is an activity on the Teams page for you to sort different items into either whether they're solid, liquid or gas, and then you're also going to be making a poster all about the properties of solids, liquids and gases. If you have any questions, then get in touch with me and I'll try my best to answer them, and if not, I'll see you very soon. Bye!